Hello Year 10, it's Miss Bailey here. In this video we're going to be looking at something called limiting reagents. So the reason we look at limiting reagents is because our reactions will proceed until one of our reactants are used up. So our limiting reactant is therefore the reactant which gets used up first in a reaction. So it limits how far that reaction can progress, because once it is used up, the reaction is going to stop. Our other reactant is described as being in excess, and that means there's more of it than is required. So I'd just like you to pause the video whilst you note down those two definitions. So what we're going to be looking at in this video is how we calculate which reagent is our limiting reagent. So again, we have a series of steps which we can follow to identify which of our reagents is in excess and which one is limiting. So the way we're doing that is we are going to be looking at the number of moles of the reagent that is needed to react exactly with the other reagent. And we can compare that to the amount of the reagent that is present, because we're given the amount of each of them. So we can calculate the moles for each of them. And we can compare how much of the reagent is present to how much would be required. And so if the amount is more, then the reagent is going to be in excess. If it's less, then the reagent is limiting. So we're going to swap to one of the worksheets now to go through a couple worked examples. So I'm going to go through question 1, and then we are going to do question 2 together. So when I say we do, it will be a case of you have a go whilst the video is paused. You then play the video to check your answer, and keep doing that for that question to make sure that you are happy with each of those steps. And then you will then have a go at the remainder of the sheet, questions 3 to 7. Okay, so for this first question, I'm going to work through this example for you. So the first thing we want to do is make sure that our equation is balanced, which it is, and then write out our ratio of reactants and products. So in this case, because there's no numbers in front of each of the substances, that tells us that it's a 1:1:1 ratio. And we are being asked which of the reactants is in excess, and also to work out the number of moles of the products formed in each case. But what I want us to focus on today is just this identifying which is in excess. Working out how many moles of the products formed, that's our reacting mass calculations. You can come back to that at another point when you want to go back over this topic and revise. But for the purpose of today, I just want us to focus on which of the reactants is in excess. So we have 3 different questions for this balanced equation. So in this first question here, part A, we have been given the amount of calcium oxide to be 2 moles and the amount of water to be 3 moles. So what we have here is the amount of substance. So this is our step 3 done for us. So for step 4, we want to pick one of these and work out how much of the other substance we would need for it to react exactly. So I'm just picking the first one, the first substance in this balanced equation, so the calcium oxide. So for all of this 2 moles of calcium oxide to react, how many water molecules would I need for all of those calcium oxide to react? So because it's a 1:1 ratio, we would need 2 moles. And so now step 4, we are comparing the amount that we need to the amount that we have. So 2 is less than 3, and therefore we have more water than we need. And so our substance in excess is our water. It's in excess by 1 mole. So we would have 1 mole of water left over when this reaction was finished. So in part B, we now have different quantities of these substances. So here we've got 10 moles of our calcium oxide and 8 moles of our water. So again, just picking the first one in the equation, how much water would I need? It's a 1-to-1 ratio, so I would be needing 10 moles. Now this 10 moles is greater than the 8 moles that we have, so that tells us that our calcium oxide is in excess and our water is what's limiting, because we don't have enough water to completely react with all of that calcium oxide. So then our third example, here we've got 0.40 moles of calcium oxide. How much would we need for all of that to react? It's a 1-to-1 ratio, so we would need 0.4. And if we compare it to 0.5, this 0.4 is less than 0.50, and therefore this 0.50 is what's in excess, because we have more than what's needed to react completely with the calcium oxide. So in question 2, can you pause the video whilst you write out the ratio between the substances? So it's a 2-to-1-to-2 ratio. So now pause the video whilst you have a go at part A. Okay, so looking at the amounts of these substances, again I'm sticking with my routine of selecting the first substance in the equation, so 2 moles. So how many moles of oxygen would I need to react completely with this 2 moles of calcium? So because it's a 2-to-1 ratio, we are needing half the amount of oxygen compared to the calcium. So we actually only need 1 mole. Now that 1 mole is less than the 2 moles that we have, and therefore we've got an excess of our oxygen because we have more of it than what we need. Pause the video whilst you have a go at part B. Okay, so in part B we have 10 moles of our calcium, and so if we think about how much oxygen we would need to react completely with that calcium, 2-to-1 ratio, we need half the amount of oxygen compared to the calcium, so we need 5 moles. And so comparing that 5 moles to what we have, we can see that that is more than 2 moles, so we need more than what we have, and therefore our oxygen is limiting and our calcium must therefore be in excess. Pause the video whilst you have a go at part C. So with part C we've got 0.5 moles of calcium. To work out how much oxygen we need, we're looking for half the amount of 0.5 because it's a 2-to-1 ratio. So we need 0.25 moles. And so comparing that to the 0.2 that we have, 0.25 is greater than 0.2, and therefore we don't have enough to completely react all of that calcium with, therefore our oxygen is limiting and our calcium is in excess. So you now have some other questions to try on limiting reagents. So again, identifying which reagent is in excess. Follow the same methods as I've been demonstrating above. Here is a summary of those steps again. In this lesson we've been focusing mainly on steps 1, 3, 4 and 5, and next lesson we will look at incorporating step 2 into this work. Thank you all for watching and see you next time.